This semester, we were tasked with working with Agilent Technologies, a global biotech company, to create a life cycle assessment for their new and refurbished gas chromatography instrumentation. Gas chromatography is an experimental technique used to separate and then further identify chemical components of a sample mixture.
Agilent's goal for this project was to use these assessments to quantify the carbon emissions between new and refurbished instruments. Agilent is currently the only biotech company with their own certified pre-owned, where they refurbish used instruments for continued use to improve company sustainability.
Through the creation of life cycle assessments, an effective quantification of the environmental impact is determined. As a result, companies can become more aware of their impact and recognize areas for improvement. The nuts and bolts of an LCA consist of defining the functional unit, the system boundaries, the life cycle model, which is well connected to the system boundaries, and the impact factor of interest.
The functional unit is the product you have interest in tracking the environmental impact of. The system boundaries outline the processes and activities of the product that will be accounted for. These are critically dependent on the data availability, resources, and time constraints. Lastly, the impact factor is the quantifiable measure of environmental impact, which for our purposes is the CO2 emissions generated by the product.
The power behind an LCA is the ability to quantify the emissions of a product through particular life stages and identify processes that are most environmentally harmful. Companies may then be inspired to revise or change operations during their product's life and ultimately reduce their environmental impact.
We would like to conclude this video by thanking the course instructors Dr. Kurzman and Dr. Sanchez, and a special thanks goes out to Naomi Cirillo and the rest of the Agilent team.